All right, so that means that our equation for the force of static friction, and I'm going to put a little max down here just to remind you, would be equal to mu static times the normal force. And that is your, you like to put boxes around it. So there's the equation for the maximum static friction force. So let's talk about units for a second. Force is measured in newtons, and that would be equal to something times normal force is measured in newtons. So what do you think this thing has to be measured in? If I need newtons and newtons on both sides? Nothing. Okay? The static coefficient is unitless. It's a number. It's always a number between 0 and 1. So you won't have any negative coefficients of friction, and you won't have any that are over 1. If you do happen to mathematically calculate something that's negative or over 1, then that gives you an indication that you've probably done something wrong. Or if it's a situation where you're trying to determine, is it possible for the object to move, and you get a coefficient of friction of 1 or greater, then it's not possible for the object to move. Okay? But if you have a coefficient of friction of 1 or better, it's like stuck. Somebody has glued that object down. It is super sticky. Okay? All right. So now let's look at the other case. It wasn't static, it was, what word would be opposite of static? Kinetic. Kinetic or moving. Kinetic's the fancy word. So in our kinetic situation, let's draw a free body diagram. So here's our little object. What was interacting with the block as you drug it to the right at a constant rate? What did we mean by constant rate? Same what? Same force, okay. So at a constant rate, what wasn't changing? The velocity wasn't changing, so what was the acceleration then? 0, perfect. So we had a constant velocity and a 0 acceleration. Okay? What was interacting with our block that we were pulling at a constant rate? What was interacting with the block? The person pulling it. So we have a force applied. Which way? To the right? What else was acting on our block? Francesca? Yeah, which way would the force be? To the left. Now instead of static friction though, it is a force of friction, but it is kinetic. So I'm going to put a little K there. I don't know. We're going to see. So what else was interacting with our block? The earth was interacting. I heard somebody say gravity. We're going to say the earth was interacting and it was applying a gravitational force. What else was interacting with our block? The table surface, and what was it doing? Pushing it up. That's right. And what did we call that upward force? The force normal. So the normal force is perpendicular to the surface. The gravitational force is straight down. Friction force is a resistant force between the surfaces. So the acceleration is 0 in this case. Now if we scroll way back up here and look at this case where it was static, the acceleration was 0 and it's in equilibrium. Okay? Now if we pop back over to a couple of days ago where we had an object that was hanging right there, was it in equilibrium when the tennis ball was hanging in the front of the room? Yes. And what was the acceleration? 0. So acceleration equals 0 and it's in equilibrium. Those two things have gone together twice already. So now our object moving at a constant speed